Welcome once again to Easy Math. Today we shall be looking at the differentiation of trigonometric functions and also the differentiation of exponential functions. Provided our angles are measured in radians, the trigonometric functions are differentiated as follows. For y is equal to sine x, dy dx will be cos x. Now the derivation, we are going to derive this. If you are given y is equal to sine x, suppose there is a change in y, a change in x of triangle x, consequently there will be a change in y of said triangle y. Now equation 1 becomes y plus change in y is equal to sine into x plus change in x. Subtracting the two equations gives y plus change in y minus y is equal to sine into x plus change in x minus sine x. Simplification gives change in y is equal to sine x cos change in x plus cos x sine change in x minus sine x. This is got from this simplification of sine into x plus change in x is got from the double angle theorem, which I will explain later on in other tutorials. So dividing through by change in x, we get the given equation. Now as change in x tends to 0, we shall have change in y over change in x tends to dy dx, and change in cos change in x tends to 1, and sine change in x tends to the same angle change in x. Now this is also easily obtained because we know that cos 0 is 1 and sine 0 is 0. Hence by substitution we get dy dx is equal to sine x times 1 over change in x plus cos x change in x minus sine x over change in x. So dy dx will be that, giving us dy dx is cos change in x times change in x over change in x, simplifying to cos x. The rest of the trigonometric functions can be derived using the same method, but for purposes of time I will not derive them here, I will just tell you what they are. If y is equal to cos x, dy dx will be sine x. And if y is equal to tan x, dy dx will be sec squared x. Now we have here an example. Given y is equal to sine 3x, so we are going to derive this. We shall use the chain rule. So our t here will be 3x. So dt dx will be 3, and y will be equal to sine t. Dy dt will be cos t. So by the chain rule we multiply the two, giving us cos t times 3. Further simplification gives us 3 cos 3x. We substitute for t, which is 3x. That will be our answer. Now we are looking at the differentiation of logarithmic and exponential functions. So given e in mathematics is equal to that figure, approximately that figure, and if we have y is equal to e pi fx, we use the chain rule to differentiate, so we get d dx of fx times the original function. So for y is equal to e pi x, dy dx will be e pi. Now for y is equal to in fx, dy dx will be, we get d dx of fx over fx. Hence d dx of in x will be the derivative of x, which is 1 over x. So we need an example for you to get this easily. If given y is equal to e pi x cos x, so we have to first identify which method will we use here. Looking at the equation, we see it's a product of two functions. So we shall use the product rule. Our u and v, we get our u and v. Our u is e power x, and our cos x is the v. So n can be u and n can be v. So using the product rule, our u here is e power x, so du dx will be e power x. Our v is cos x, dv dx is negative sine x. So dy dx will be v du dx minus u dv dx, which is cos x times e power x minus e power x sine x. So further simplification gives you that. That will be our answer. Thank you so much. Remember to like, share, subscribe for more math tutorials, and in case you have any questions, feel free to put it in the comment section. Thank you. See you in the next tutorial.